Okay, so what are we doing today? Common Core, we're basically factoring perfect cubes. And what I want to do is make sure we have those numbers, factoring perfect cubes. And let's write them all down up here, okay, the perfect cubes. Let's write down the ones we need. Let's write down 1, 8, 27, 64, 125, 216, and 343. And I don't think the book will ever ask you to go anything bigger than that. But we have bigger ones in our reading, right? We went all the way to 1,000, right? So we want to be able to recognize these, okay? So that's the same thing as 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed, okay? All right, so example 1. And in fact, I put the formulas up here because I always know it's a squared, a. I always know the form, but I always forget the signs. So it's like plus, minus, plus, and this one's minus, plus, plus, right? So basically almost the exact same formula except for the fact the signs are different. So here they are. There's our perfect cubes, all right? So right off the bat, example 1. It really is the first one. It is. Instead of a cubed, it's x cubed. Instead of b cubed, it's 2 cubed. You can see the 2 cubed? The 8's 2 cubed, right? You guys good with that? So let's rewrite it. Let's write it exactly like that. So instead of a cubed, it's x cubed plus 2 cubed, right? So if I use my formula then, my a and b are x and 2. When I use my formula instead of a and b, I'm going to use x and 2. Does that make sense? So all we have to do now is just put them in and we'll be done. It can be that easy. I'm cross my fingers so it's easy, okay? So a is really going to be x and b is really 2. So my answer is just simply going to be x plus 2 parentheses x squared, okay, x squared minus ab, which is going to be these two together. 2x, see the 2x, these two together. 2x plus b squared, which is going to be 2 squared, which is 4. Okay, I'm going to step back and let you think about what I got up there, okay? All right?
It's just remembering the stuff.
Okay. It's actually not hard, is it?
Plus,
Okay. So, here's my, this is my 2 cubed, you guys, or my 2 squared. So b is 2, right? So 2 squared is 4. You guys are with that? Yeah. And this 2x is 2 times x. I could write it as x2, but it should be 2x. Okay? Thumbs up. Okay. Sideways. Okay. All right. Let's do another. Okay. So the next one's the same stuff, except for instead of 8 cubed, 8 is a perfect cube, right? What would 8 be? What number do I want to use? 2, right? 2 cubed. So I'm going to rewrite this as a 2x cubed. And 27 is a perfect cube also. What is 27? 3 cubed, right? 3 cubed. So in this case, and sometimes this might make it a little bit easier. You okay in how I got this? I know 8 is a 2 cubed. 27 is 3 cubed. So if I write on the side that in this case a is 2x and b is 3. Does that help if I write on the side that, let's let a, right? A is the 2x and b is the 3. Then we're just going to plug it into that formula right there, okay? So let's go parentheses a, which is 2x minus b, so it's minus 3, okay? So I plug the 2x right in for the a and the 3 for the b, okay? Then parentheses, a squared. So what is this squared? What's this squared? What's that squared?
4x.
4x.
Squared.
4x squared. Yes.
Would b be negative 3?
Great. I was hoping somebody asked that question. So you have two choices. If you make it negative 3, then you don't even need a second formula at all, right? You with me? But if you treat it as a subtraction, it just takes care of itself with the other formula. Are you with me, Austin? So yes, you could do it that way, and you get the same answers, okay? Real good question. I was hoping somebody asked that. Okay, so I'm going to have a 4x squared here because a squared, or 2x squared is a 4x squared, okay? Now, AB is these two, which is going to be a plus 6x, okay? And then plus b squared. B is 3. What's 3 squared? Plus 9. Thumbs up? Let me see. Okay, it's not so bad, is it? Okay. As long as you know your perfect cubes, right? Knowing your perfect cubes helps a lot in this. You agree with that? Okay, and then just setting them up, okay? Carlos, you're thinking. I like that. You're thinking hard. Okay, how about the next one? Now the next one, before you do anything, 5's not on this list, is it? And 40's not on this list, is it? But what I recognize is that before we do anything, we can common factor. Okay? Before I do anything, I can common factor, okay? So what do they have in common? And an x. So it's common factor at the 5x, okay? And let's see what's left, okay? If I factor out the 5x from both terms, so if I take out a 5x, what's left here?
X cubed.
Good, good. X cubed is awesome. Plus what?
8.
Ah, now it's exactly like that one, isn't it? Isn't it exactly that one? The one right above it. Isn't it exactly like the one above it, right? So, I'm going to do it step by step anyway. So it's a 5x times an x cubed plus a 2 cubed, right? 8 is 2 cubed, right? Agree with that? It's one of our special ones up here. There it is. There it is. 8. 8's 2 cubed, okay? So, let's use our formula. So our formula is that one, right? Because the plus, it's that one right there. So keep the 5x out in front. And our formula says a plus b, right? So a is x and b is 2, right? A is x and b is 2. So let's go our x plus 2 parentheses. We're going to go a squared is going to go x squared, right? A squared, we're going to go x squared. We're going to go minus ab, so we're going to go minus 2x. And then we're going to go plus b squared, so we're going to square 2 and go plus 4. Okay, it's not that hard, is it? It's easier than doing these. You agree? It is easier than doing these. Okay? Thumbs up? Thumbs up, okay. I see one thumb up. 2, 3, I want to see thumbs. And if it's not thumbs up, give me sideways. I'm okay with sideways. Okay? Sideways is okay. I just need to know, okay? But at least we're not here, right? You agree? If we're here, then I need to know, okay? Okay, turn the page. Okay, example 12. 125. What do you think? 125. Okay. 5 cubed. Very good. Totally right. Nice job, Gage. 5 cubed minus. Now this one's a little tricky. What do you think? Anybody have an idea on this one? It's x squared cubed. Yes. Do you agree with that? So it is a cube. It is a cube and a cube, isn't it? So it is, nice job, that one there. Okay, it is that one there. So let's, sometimes it's easier to write down what A is. A is 5 and B is x squared. I mean, if that helps you write on the side, does that probably help write them on the side? That A is 5, B is x squared, okay? So then I'm going to use that one. And Austin, yes, a great question. You can use this one, but you have to be careful of the negatives, right? You'll get the exact same thing. But it's easier just to say, call it a subtract instead of a negative, right? So let's do it, okay? So we're going to go A minus B. So I'm going to go my 5 minus x squared. Because A minus B. Parentheses, I need my A squared. So I'm going to go my 5 squared, which is 25, right? And then I'm going to go plus AB. So AB is 5x squared, right? Plus 5x squared. And then plus B squared, which is x squared squared. X squared squared. Yes, plus x to the 4th. Now, sometimes kids try, and not you guys, because you guys are smart at that. Sometimes kids try and factor this stuff again. But it can't be factored again. Because if it could be factored again, it wouldn't be in this form, okay? And it wouldn't factor anything. This one could be factored, but then you'd have to use the square root of 5, and that's just ridiculous, okay? Okay, now, how about this one? Example 13. Am I going too fast? You guys okay on the answer? Okay, how about example 13? It's that one, isn't it? It's that one. It's not factoring at all, is it? You see the difference? This is not factoring. This is going to be Pascal's triangle, okay? So, x cubed negative 5, 0, right? I sure can, okay? Remember how we go and make it go 3, 2, 1, none. So we're going to have an x squared negative 5 to the 1. We'll have an x to the 1, negative 5 to the 2. We'll have an x to the 0 and a negative 5 to the third. It's a different type of problem. It's not factoring at all. It's a completely different kind of problem. It really is an expanding problem, okay? Now, third row of Pascal's triangle. Let's put up there real quick. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, right? So why am I using the third row? Right? Because of the cube, right? You guys agree with that? So let's put Pascal's triangle in there. Let's put our 1, 3, 3, 1, okay? And we'll finish it up. So anything to the 0 power is really 1, so this just kind of disappears, okay? You have that? So I get a 1x cubed, a plain old x cubed, okay? This is just negative 5 times 3, which is negative 15x squared, okay? Okay, got a little bit careful here because negative 5 squared is a positive 25. Positive 25, okay? Because the negative squared, positive 25, so 25 times 3 is 75. So I get a positive 75x. X is 0, we don't need that. It becomes 1, right? Negative 5 times negative 5 times negative 5 is a negative 125. Negative 5 times negative 5 is 25 times negative 5 is a negative 125, okay? There we go. All right. So 1, 2, 3, 4, 5, 6, 7 of these. And most of them are going to be like this, which are not too hard, right? So it is Friday. Let's try and get this done in class so we don't have to worry about anything over the weekend, right? Yeah.